So the last part of chapter 13, all we're going to do is what we did yesterday, but we're going to do the confidence interval for the slope. So today we're basically looking at what do we think the slope would be of the true regression line. So the conditions don't change. Random sample from yesterday. No apparent pattern in the residual plot. Linear regression. Again, we're going to do t-interval. Yesterday we did t-test. And then B, make sure you're defining that as the true slope in context. Okay, so the true change in whatever. List the slope, the standard deviation of the slope, the t critical value, and the degrees of freedom. Remember, your degrees of freedom is n minus 2. And you're basically just going to calculate this without using the calculator. Again, you can use the calculator. There is a test, but you need the actual data for that, which they don't normally give you. They'll normally give you the Minitab output like we did yesterday. And then your conclusion, we are however percent confident that the true mean increases or decreases by between whatever with each increase in the explanatory variable in context. And then your second sentence is the response variable increases or decreases with an increase in explanatory variable. So that makes more sense when you actually do the problem. So we're going to take the data from yesterday. What is the margin of error with a 98% confidence interval for the slope of the regression line? So yesterday we were looking at percent body fat versus age. So our slope yesterday was something. 0.5480. SB, which was the standard deviation of the slope, was 0.1056. So if it's asking you for margin of error, your confidence interval formula is the slope plus or minus T star times SB. Remember, with confidence intervals, if it's asking you for margin of error, it's just asking you for this section. It's just asking for that section. Our degrees of freedom yesterday was 16 because we had 18 random people. So if I go to my formula sheet to get my T star, I'm going to go to the T table. I want row 16, 98 degrees. So row 16, 98. So 2583. So that's our T star, 2583. So we're going to take 2.583 and we're going to multiply it by our standard deviation. So 0.2727%. That's our margin of error per year. So that's how much we're giving ourselves for the slope.
0.27%?
No, it was already in percent. So we don't have to convert it. It's already in percent. Okay, so now let's calculate a 95% confidence interval for the slope of the regression line. So our conditions, I'm not going to write them all out because they were the same as yesterday. So 1, 2, 4, see other page. But this time we're going to do a linear regression t interval. Like on your test or on the AP test, sometimes it'll do 2 inference procedures in one problem. when you have that, for conditions 1, 2, and 4, you can just say like C above or C whatever. And then just make sure you name your test. So for the testing, remember there's no hos and ha's when it comes to a confidence interval. So we have our slope, which again I wrote down 0.5480. SB was 0.1056. N is 18, so our degrees of freedom is 16. So we have a new T star. So I'm still going to stick with 16, but now I'm going to go to 95%. So 0.212. Or 2.12. Then, this is your formula. It's just the slope plus or minus your T star, that should be T star, times S sub B. So it's just your slope times your T critical value times your standard deviation. So 0.5480 plus or minus 2.12 times 0.1056. And then just use your calculator to calculate the endpoints. Let's put it over there. So there are my two endpoints. So I just do the plus, then do the minus. So 0.3241, 0.7719. And then we just have to interpret this. Now, just like we did in chapter 11, we got to talk about what happens when both endpoints are positive, both endpoints are negative. So our conclusion, we are 95% confident that the true mean percent body fat increases between 0.3241% and 0.7719% for every additional year in age. Now your second sentence should comment about the fact that they're both positive. So because they're both positive, again, not one stronger because you're still just doing it the slope, kind of explain what a positive slope is. As the percent, no, as age increases, the percent body fat increases. So as your X increases, so does your Y. Okay. I think. No. If these were both negative, you would say as age increases, the percentage of body fat decreases. If there was 0 in here, what should happen is we should fail to reject in our test, meaning that there's probably no association between the two variables. So you would just have to say that. You wouldn't want this. You could say because 0 is in the interval, there could be no association between the two variables. Okay, let's try our last one. It says it's your turn, but we'll do it together. So the data here is collected in certain regions of Great Britain, Norway, and Sweden to study the relationship between the mean annual temperature and the mortality rate for a specific type of breast cancer in women. So you're given the least squares regression line already. Here's your residual plot. remember from yesterday, this first one's the y-intercept, and we don't need the rest of that row. This is your slope. This is SB, standard deviation of the slope. This would be your t if we were doing a hypothesis test. This would be your p-value if we were doing a test, but we're not going to do a test. This s is SE. We don't need r squared adjusted. Then this is SS residual. S is total. You don't need those. And basically our n, this is our degrees of freedom, so n should be 16. Use this data from a random sample to answer the following questions. So find and interpret the value of SB. So that's from yesterday. So 0.3489. Remember, SB is just the standard deviation of all the slopes. So it's how much we expect the sample slopes to vary from sample to sample. And then we have to interpret SE. So again, two different, one's the standard deviation of the slopes, one's the standard deviation of the residuals. So the value 7.545 measures the typical amount of variability in the vertical distances from the mortality rate, bless you, to the least squares regression line. Okay, now let's do find a 95% confidence interval for the slope of the regression line. So for your conditions, first condition is, are you looking at a random sample? Yes, it was given to us in the problem. Data is from a random sample. Two, you want to look at the residual plot, which I gave you. Does this look like there's a pattern? No. Let's say no. So the residual plot shows no pattern. Therefore, our linear model may be appropriate. Now I think on your homework, they may just tell you the conditions have been met. So again, you just skip 1 and 2. Say 1 and 2 have been met. So this is a linear regression t interval. And then we gotta talk about our slope. So we're looking at the mean annual temperature and the mortality index. So beta is the true change in mortality index for each increase in mean annual temp. Again, you don't need a hoe and a half for a confidence interval. So for the testing section, let's list everything. Our slope here was 2.3577. Standard deviation was 0.3489. N was 16, so our degrees of freedom is 14. So we got to find a T-star. So go to your formula sheet, row 14, we're doing 95%. Point 2145. Or 2.145, you get it. And then just do the actual math. So it's always your slope. Let's put it right here. Plus or minus T star times the standard deviation. And then use the calculator to calculate it. I always do the minus first. So your intervals from 1.61 to 3.11. We'll just round to that. And I don't care really what you round to. Everybody kind of rounds to something different. I'm not like super picky like we go. Just don't round to a tenth, hundredth, or past that. Okay, let's write our conclusion. We are 95% confident that the true change in mortality index is between 1.61 and 3.11. I think we just say people. For every increase in mean annual temp. And then basically just explain what the positive slope means, because both endpoints are positive, so we know it has to have a positive slope for sure. As the mean annual temp increases, mortality index increases. Okay, questions at all?